Welcome to the session. Greeting of the day. In today's class, we are going to talk about the plastic deformation processes. We are dividing into two categories of a bulk deformation categories process and a sheet metal deformation process. Both are deformation, but I am using the word one for bulk deformation, which is we are going to use for more thickness, high thickness materials. And one more I am telling as a sheet metal deformation process is we are going to use for less thickness materials. So the sheet metal process you will see later. As of now, I am starting with the bulk deformation materials. Now we will start with one by one. Of rolling, we have to see, and next forging and extrusions we have to see. So the deformation process in which work thickness is reduced by compressive force. Work thickness we are going to reduce. This thickness we are reducing by compressive force. The rolling process of especially for flat rolling. This is about our flat rolling operations. The thickness reduction. I have used the two rollers. The top roller is rotating in the anti-clockwise direction. The bottom roller is rotating in the clockwise direction. In such a way, this pushes the specimen, and here you see, here the large thickness is there. This thickness has been reduced here. This thickness has been reduced there, and we are taking out. So such possibilities are possible. So this is how some images I want to show you. That is, see the roller, how the roller setup is there, and how we can able to look over. You see how they are making the rolling operations, coming inside and going up there. Plate thickness has been reduced. So such examples. The rolls. Now we want to see about the different type of rolling operations. What are we are going to do? See, based upon the workpieces, we could have a flat rolling process or with a shape rolling process. Until now we have talked about rolling itself for thickness reduction. That is a flat rolling. So this is what we have mentioned here about a flat rolling process. So thickness, a flat, it is going straight flat, thickness reduction. You see, a rotation of rolls perform two main functions. What are they? The roller is going to rotate now. So this roller is going to rotate. These rollers are going to rotate. What it does? Mainly it is going to compress. The pulls the workpiece into the gap. Pulls the workpiece into the gap between them by friction happening. By the friction between the work part and the rolls. So we have rolls, two rolls, this and the one more workpiece is going to in contact here. The workpiece is going to be in contact here. The workpiece is going to be in contact here. So therefore it is going to compress. So this zone is a contact zone. So this zone is the contact zone. We can understand. So this zone is the contact zone. So you see, this zone is the contact zone where it is going to compress. Friction is going to happen. Simultaneously we are giving the force also here, pressure. Squeeze the work to reduce the cross section. So this is also happening. Now I am dividing some based upon the workpiece geometries of flat rolling, shape rolling. Use it to reduce first one. Use it to reduce the thickness of the rectangular cross section material. What is a rectangular specimen? We have taken this specimen and I have mentioned the roller here, and it is coming inside. Therefore when it is coming inside, we are getting a contact here. This friction happens, and again it is coming outside. When it is coming outside again, here there is no contact, but the reduction of thickness has happened. Reduction of thickness happened from maybe from 10 mm to 8 mm. So likewise, here what happens here, I am giving a force has been given on the rollers. So likewise, so thickness from the rectangulars to the other cross sections. So shape rolling. Maybe a square cross section is formed into a shape such as I-beams. Such other shapes can be performed. So rolling, flat rolling, types maybe shape rolling process. Now I am dividing the same rolling process into other way of what is the working temperature of the rolling process. We know this. This is nothing but maybe rolling can be done at cold working conditions. The same rolling can be done at hot working conditions. That is what in the first we have seen. So this is what. So this conditions, maybe rolling may be a hot working, maybe a cold working. I am considering this warming as also a hot working process. Now you see, therefore, it may be a hot rolling process, or otherwise it may be a cold rolling process. Most common due to large amount of deformation required. We undergo the hot rolling process where the large thickness material to be deformed, or otherwise a large shape to be deformed. At such cases we are going to hot rolling. Cold rolling, where when we are performing a cold rolling, produces the finest sheet or plate stock. Simple, up to 6 mm, let us consider 7 to 8 mm thickness plate. It can be pressed easily. It can be deformed easily. And at that stage, I am not in need of hot conditions. I am not in need of any warmer conditions are not required, because it is 8 mm can be, by simple force it can be able to deform. Simple force we can able to change the shape. By simple force we can able to change the thickness. So at that time, I am not need of this cold working process. So I am not in terms of temperature, not needed. Now the thickness is increased. Force, I can't able to give more forces are needed. Then more loads are needed. Machine setup will become large. At that condition, I am just heating and material getting readily deformable. The word I am using, readily deformable. And then we are pressing forces given. It can be little bit convenient to change the shape. That is why hot rolling and cold rolling. So I have divided the rolling process into flat rolling, shape rolling, hot rolling, cold rolling. So how I am changing other shapes, you see, I have taken up blooms of this condition of rectangular bloom. Shape rolling process I have done. 2 rollers I have kept here, and the I sections for the rail, for the usage of rails we can able to form. Otherwise, I have taken a slab, and this thickness has been reduced. This height thickness has been reduced. Slab into, I have converted into plate and sheets. You see, I have converted into plates and sheets, low thickness, high thickness to low thickness, and the coils, small thickness I have reduced. Otherwise, I have taken a billet, so small rectangular billet here, so small rectangular billet I have taken, and I converted into bars and rods. So I converted into bars and rods I can able to convert. So such can be performed by the rolling operations. Before going to the various types of rolling process, we should know a few things about the nominal culture of this setup. How the rolling process, we are mentioning this. Or the roller radius. So we have a roller radius here. Such cases we are mentioning, this is a roller radius. So from the center I have taken as a roller radius, this one, and then the roll pressure, how much pressure we have applied. It's I am mentioning this as a roll. Here itself we are applying pressure because it should be in contact and it should give the force for the thickness reduction. Therefore we need a force there. Roll pressure I am giving. Here is the pressure. Roll pressure I am giving. And then L I mentioned is a contact length. Where is the contact length? You see, here we are trying to mention this is the contact length. 2 rollers, specimen is coming. This is the contact length. And then it is going to relieve. Here it is a contact length. And then it is going to relieve. So these 2 zones I am mentioning this as a contact length. Now, contact angle. What is the contact angle? This here we are doing I am mentioning this is the contact angle, you see. Here, this one is the contact angle theta. So, contact angle. This zone, contact length and the contact angle, this zone. So, this zone is a contact angle. Now, we are roll speed. How fast it is, roller speed is given as an input. How fast this roller is rotating, that fast there, it will drag, it will create the friction, it will drag the workpiece inside. So that is what I have mentioned this as a VR. So VR, roller speed, VR. So how far it is going to drag. One is going to rotate in the anti-clockwise direction, one more is going to rotate in the clockwise direction. In such a way it will roll. Next, initial plate thickness, T0, this one. So this is the initial plate thickness. Here, first thickness plate may be as we have mentioned, this is a maybe 10 mm for example. So this is nothing but a T0. Now, final plate thickness. From this side, it is friction, force applied, it is coming out. So this is the, we are understanding maybe like 8 mm. I mentioned this is a TF, right? TF. Plate entry speed. How fast plate is giving? Roller is rolling speed, that is. But how fast I am pushing the plate? Both speed works together to come out. How fast it is dragging? How fast it is pulling? I am not pulling. I am keeping here. It will keep on rolling, will be slow. But I am pushing here. Therefore, both forces will act in such a way it can come easily. The force can come, the product can come easily. Otherwise, force, for sure, force needed. Then only it can move. Then only it can force to apply, to contact, to create friction. Therefore, plate entry speed, plate exit speed. So, how fast V0? Here I have given how this plate entering. You see, the plate entry speed I mentioned as a V0. Here, this V0, and then the plate exit speed. Plate exit speed I mentioned this as a VF, exit speed, finishing speed. Okay, so this is how a few points we should know about the nomenclatures of how the rolling operations to be takes place. Flat rolling and its analysis. From the previous equations, we can able to conclude the following, that we should see this one by one. Rolling operations. The various configurations of rolling mills. We have some 4 to 5 setups are there at different types of rolling mills. It means the types of rollers, how we are equipped to do the operations. So that is what, one by one you see. Number 1, this is what we keep on seeing now. Nothing, it is named as two high rolling mill. Two high rolling mill operations. Generally, we are keeping inside force applied for movement, force applied for friction contact, and it comes out. Velocity of in, velocity of outside. So this is how generally it moves. Now I am coming to the next one of 3 high milling process. What happens here? We have one more roller at the bottom. What I want to do? Let us consider, for example, I want to reduce from thickness of 10 mm to 6 mm operations. What happens? This machine setup is capable of giving the reduction of 10 to 8 mm only. 10 to 8 mm only. Then what I have to do? I have only one machine. I am going there, a long lengthy plate I have taken. I have, once rolling operation has been done, the plate which is here from here to here, it rolls and it comes this side. Now what happens? After coming this side, I have to take the specimen again back to the initial position. Again from the initial position, I have to drag again. This process makes very, very large space, more manpower, because this lengthy rod we are not, let us consider for example of railway track. It is to be compressed, let us consider. So we have to go inside, you have to take, after completion, you have to take and come again, and you have to insert again. So to reduce this complexity, what I am doing, I am inserting one more roller here. It means I am not purchasing a new setup of 2 rollers, or otherwise second machine I am not purchasing. I am attaching one more understanding, otherwise we can able to perform in such a way that after taking out the same specimen, multiple it is going to work. You see, here one roller is used as a common. This roller is used as a common roller. You see, this roller is used as a common roller. So this is rotating at anti-clockwise. This is rotating at clockwise. And again, below one is going to rotate at anti-clockwise direction. Both rotating at anti-clockwise, its center is rotating at clockwise. So what happens? The specimen which is going in, I can able to take out that side. The same specimen I can able to keep it here in such a way. Next thickness will happen from 8 to 6 mm. 10 to 8 happened that day. With the same setup, I have added one more roller. Therefore, this machine can be again operated here in such a way. The operation I am making comfort, cost reduction I am doing, multiple operation I am doing, time saving I am doing. So these are the advantages of this 3 high rolling mill. So we have 3 here, 3 rollers. Here we have only 2 rollers, and we have 3 rollers to make reduction of thicknesses. So how I can do this? So I am keeping like this. I am doing, first I have taken and I am setting in the same way in this route. So likewise you can able to do this. Next, I have 4 high rolling mills. What I have did here, you see, I have utilized 4 rollers. This roller having a large diameter, this 2 having a large diameter, and it means we are taking a shaft output from the motors and we are connected to this rollers in such a way the motor runs slowly, but I want output more faster. Therefore, I have included a small roller here in such a way for a single rotation of the large roller, multiple rotations of smaller roller will happen. If multiple rotation of smaller roller is happening, this thickness movement also will be in contact more. This contact also will take more contact, more specimen movement can be done. So I am easing the process by addition of more rollers here with respect to large to small rollers, more contacts, more reduction, cost effective, time reduction. We are doing this 4 high rolling mills. This is one more method of clustered rolling mills where multiple rollers are used to same methodology. Instead of 4, I am using the clustered method. 1, 2, 3, 4, 5, 6 I have used. So here also the faster time consumptions, motor low speed to high speed, those things we have carried out. But the final result is large thickness to less thickness, from 8 to 10 to 8 likewise. So this is about a 4 high rolling, clustered rolling. Now you see, I have used the 4 high rolling mill. I am naming this as a tandem rolling operations. So what I have done as a train like an operation, like a train like operation, here the thickness which is started is around 10 mm. One operation has been done and it is coming out. Why it is coming out? I have added the other end nearby. I have added one more roller and I have reduced this thickness, which means the gap I am reducing. From here I have this gap. When it is coming here, the roller gap is again reduced. When it is coming here, this gap is further reduced. What happens therefore? Therefore, the distance, the thickness is further reduced here. The thickness is further reduced here. It means from 10 mm it is converted into of 8 mm. It is 8 mm. So this is 8 mm So here we are getting an output of 8 mm, and this 8 mm is going inside, coming output of 6 mm, and 6 mm is going inside, it is coming out of maybe 4 mm. So likewise, for example I am telling. So likewise we can able to go. So this is the velocity of V0, V1. Here the V0 is coming in, and next V1 velocity, because when the thickness is reduction, we are moving. So V0, V1, V2, V3 are another variables of rollers we are getting in contact. So this is our naming as a tandem rolling mill. 2 high rolling mill we have seen, 3 high rolling mills we have seen, 4 high rolling mills, clustered rolling mills, and then finally the last tandem rolling mill we have seen. This is about what are the various shapes we can able to form by the image. You see, by the image we can able to form the bars. We can able to form the bars, channels, I-beams, railroad sections. Where we have seen this? We have seen here. You see this image. So rails, plate sheets, coils, bars, and rods by using the rolling operations. That is what various shapes we can form through rolling treatments. Here I want to how this I section are made, or H section how it is made. A simple mechanism from where it is started. We have taken the bloom operations. From bloom has been taken. From the bloom we are furnace heating, and the roll milling operations or edge milling operations has been done. After that these blooms are converted rollers. You see, some multiple rollers I have kept here. Multiple rollers. Through these multiple rollers, I am pressing. One roller is here acting, one roller is here acting, one roller is top acting, one roller is bottom acting. So all rollers at sides compressing to form a H figure. So likewise we can able to do some multiple shapes. One more rolling process is there, named as a thread rolling operations. In this thread rolling operations, you see, it is also a bulk deformation process used to form threads on cylindrical parts by rolling them between the two dies. Yes, we are going to use a two die mechanisms oppositely, and in between I am going to send. In between I am going to send this. So this is the die 1. This is die 2. This die 1 contains the thread design. This die 1 contains the thread design. It's like this. So here it is the start of the cycle, end of the cycle. What happens? This dies containing a threads. You see, threads are there. A design, what we need. Therefore, on the die, I am keeping a blank, which is kept inside, and one is fixed. I am keeping one die is fixed. In the start position I am trying to move, roll. Therefore what happens? Due to rolling action, this blank also keep on rolling with the operation of forcing. We are rolling like this. We are rolling like this. So when it is rolled, what happens? The impressions which are available in the die with respect to force applying, we are rolling like this. So what happens? These impressions are followed on the blank. Likewise, and finally we can take the output. Here you can see. Those we have threads here. So we have threads are formed. So likewise, see, bulk deformation process is used to form a threads on the cylindrical part. First we have taken a cylinder. This is the cylindrical part. By rolling them between the two dies, of die 1 and die 2. So likewise we can able to take. So most important commercial process of mass production. We are doing the mass productions of what we are doing. Mass productions of bolts and screws. We can able to do this performed at a cold working up, because the thickness is less, the product is very less. Immediately by forcing we can able to change the shapes. Therefore it is a cold working operation. It's possible to do. What are the advantages of thread cutting, maybe thread machining process? High production rate, better material utilizations, stronger threads we are getting because we are compressing. Compressing itself, the volume is not changed. Only the product is converting to one form to another form. Therefore, there it is strengthening or all occurred in this cold rolling of threading process. So, if you may just for our understanding. So, likewise, we can able to create some products. So, it's the same with multicolored. So, here it started and rolling, and finally we are getting the thread on the object. One more part is there, such is named as a ring rolling operations. What we are doing, the deformation process in which a thick walled ring of the smaller diameter is rolled into a thin walled ring. This thick walled ring is converted into a thin walled ring of a large diameter. How I am doing, you see, I have taken a smaller thick walled ring I have taken, thick walled ring I have taken. This is thick walled ring I have taken, and the small ringer, thick walled, smaller ringer, smaller diameter, thick walled, smaller diameter, to thin walled, large diameter. You see, thick wall, smaller diameter I have taken, and I have used multiple die rollers. See, here I have used ideal roller, which is going to reduce the thickness. It is going to reduce the thickness. The feed pressure is given here. Pressure is given here. And we are pressing, and it is going to reduce. Keep on trying to compress. Keep on trying to compress. At the same time, if it is compressed, where it will go? It is trying to move towards the upward. It is trying to move towards the downward. But that force also I am changing. I have here the radial rollers. You see, here and here I have two radial rollers. Therefore, when it is pressed, it is trying to come out. Maybe this working process we can consider as a hard working operations. So it comes out. At the same time, I am pressing this also. And simultaneously it is trying to move somewhere in the outer diameter. Therefore, slowly we convert this large thickness, small diameter to small thickness. Thickness is reduced, you see. This thickness has been reduced from here to this large thickness has been reduced to small thickness. And this small diameter has been reduced to this large diameter. Right? So that is how the ring rolling process can be done. That is why it is named as ring rolling. Ring rolling is used to reduce the wall thickness and increase the diameter. Wall thickness has been reduced, diameter has been increased. So ring rolling operation. So such cases are possible. So the summary. In today's class we have seen about the bulk deformation process. Bulk deformation process. In this bulk deformation process we have started with the rolling. In rolling we have seen about some various classifications of 2-high rolling, 3-high rolling, clustered rolling, tandem rolling, and then we have seen about this thread rolling, and also we have seen about this ring rolling. The remaining part of the subject, we'll see you in the next session. Thank you.